We are doing carbon and its compounds, and today we'll be doing chemical properties of carbon compounds. The very first chemical property is combustion reaction. And what is combustion? You'll know very well. When any carbon or carbon containing compound is burned in the presence of oxygen. Okay, so what we have to do here, we have to heat this in the presence of oxygen. So carbon dioxide is produced along with some water vapors, and heat and light is produced. You must have seen that whenever we burn any fuel is basically either carbon like coal or charcoal, or it is a hydrocarbon. So when they are burned, we will be getting carbon dioxide gas, which will go into atmosphere. Water vapors are formed, which will evaporate, and we get flame. Not every time, but we are able to see the burning process. That is, light and heat energy is released. So this reaction is highly exothermic. Exothermic reaction means when heat is evolved. Okay, so we can see with the help of a specific equation the combustion reaction. Like for example, when carbon is burned with oxygen, you will get the same product: carbon dioxide, heat and light. Since we do not have any hydrogen, therefore we are not having any water here. We don't have water molecule in the product side. Next is methane gas. When methane gas is burned in oxygen, we will get carbon dioxide, 2 molecules of water, heat and light. Now what is CH4? CH4 is methane gas. It is a gas, so you can show in subscript gas, and it is the main constituent of natural gas or CNG, that is compressed natural gas. And because of this large amount of heat released, your methane is used as the fuel. Next is next compound which we are which is undergoing combustion is ethanol. This compound is ethanol. So for ethanol, similar reaction is there. We will be getting carbon dioxide, water, heat and light. One thing that you have to remember, that whenever and why we are calling hydrocarbon or carbon source of carbon as fuel. Why? Because they are source of heat energy, which we use for different purpose. Okay, and for every reaction, what is the basic necessity for your combustion process? We require oxygen. There is a reaction with oxygen, and since here we are adding oxygen, so all these reactions which we have written here, these reactions can also be called as oxidation reaction. Okay, these are also oxidation reaction. That is, combustion is also oxidation. And what type of oxidation? Complete oxidation. What is complete or incomplete? Now we will discuss in next reaction. So complete oxidation means this is the last product. After this, no more oxidation is possible. Okay, why we are calling it as oxidation? Because we are adding oxygen. Addition of oxygen is oxidation. Okay, next is if we have different type of fuel or hydrocarbon, we are having this the amount of light energy and type of light energy that we are getting is different. How it is different? When any saturated hydrocarbon undergo combustion, we get a clean flame. Clean flame means there is no smoke. Okay, and it is a bit transparent or translucent in nature. But if any unsaturated hydrocarbon undergo combustion, we get a sooty flame. Sooty flame is that it is very bright yellowish flame with lots of smoke. Okay, so suppose in your kitchen you are using this unsaturated hydrocarbon, then in that case all the utensils that you will be using for cooking, they will have lots of smoke. Okay, but your sooty flame is not found only in case of unsaturated hydrocarbon. One more condition is there where we get a sooty flame. What is that condition? Third condition is that when your any saturated hydrocarbon undergo your incomplete combustion, that is we will not have the final product of combustion. And when it will take place? When we have a limited supply of oxygen. Okay, so when supply of oxygen is limited, so your even saturated hydrocarbon gives you what? Clean flame. But saturated will also give you a sooty flame. Okay, saturated will also give you a sooty flame, and or lots of smoke will be produced. Fine. So whenever we are burning, that is, we are bringing about combustion of any compound, what type of flame we are getting, we can decide type of fuel undergoing combustion or hydrocarbon undergoing combustion. But for saturated one, it will be confusing when supply of oxygen is not sufficient. Okay. Now, one of the example of this, that limited supply of oxygen. Now, question arises, what are the conditions where we are limiting the supply of oxygen? Like, for example, when in your kitchen, when air holes of your gas stove are blocked. Okay, suppose they are not clean for a long time. In that case, we are not able to provide sufficient oxygen because holes are blocked, and therefore we will be getting a sooty flame. So what is the reason? When your gas stove, holes of the gas stove are not clean, then these holes are blocked, so we are not able to supply sufficient amount of oxygen, and therefore even a saturated hydrocarbon will give you a sooty flame, okay, in place of blue flame. But if we clean the holes, then again we will get a blue flame or a clear flame or the clean flame. Now, when we burn coal or petroleum, okay, when we burn coal or petroleum, always remember, in addition to carbon dioxide, we get oxides of sulfur and nitrogen, which are the main pollutant. And why we have oxide of sulfur and nitrogen? Because either your coal or petroleum, they have some amount of nitrogen or sulfur in them, and this nitrogen or sulfur, when it undergo oxidation, it will give you their oxide. Why oxidation? Because we are burning in the presence of oxygen gas or air. Okay, so this is the reason why we get all these pollutant when we burn coal or petroleum. Why we get these pollutant? Because nitrogen and sulfur present in these compound in a very small amount even undergo oxidation in the presence of air. Okay, next thing which is very important to remember is that flame, when we burn any fuel, flame which is produced, okay, it is only produced in the cases when any gaseous substance burns. What is the meaning of gaseous substance? Gaseous substance means which is having the free atoms. We are not having any complex compound. Okay, so flame is produced only when we burn any gaseous substance or the free atom. So you can understand this in this way. Like, for example, we are having some coal or wood, like, or charcoal or wood, okay, and we heat this in the sufficient supply of air. So you must have seen that when the wood start burning, it gives you flame. okay, in the beginning, but after some time wood will only glow, but it will not be having a proper flame. Why this happens? So reason for this is that when we heat wood or charcoal, volatile substance which are present in wood or charcoal, they get vaporized. Or what is the meaning of this? Those substances which can convert easily into vapors, they get converted into vapors when we heat wood or charcoal. Okay, and when they comes in vapor, we are getting free atoms. So when these atoms burn in the flame, we will be getting a proper flame in the beginning, that is visible flame. Your burning process is visible to you, but later on when all the volatile substance which are vaporized, they get finished off in wood, then we will not have flame and your wood will only glow. Okay, one more thing, different substances have different types color of the flame, like each substance produce characteristic flame. So sometimes color of the flame is also helpful for us in telling that what type of substance we are heating. Next reaction is oxidation. Now first one was combustion, which we called as complete oxidation, and next this one is your oxidation reaction, and what we are saying this, we are calling it as controlled oxidation. Okay, so what is the meaning of this? Always remember that we have a sequence of oxidation, that is oxidation does not take place in one step. Like for example, when we have any hydrocarbon, and when hydrocarbon undergo oxidation, okay, so we will first get, if we control the condition, under control condition, we first we will be getting alcohol. Okay, first we will be getting alcohol. If further we will bring about oxidation, then we will be getting aldehyde or ketone, depending upon what type of hydrocarbon we have taken. If further we bring about oxidation, we will be getting carboxylic acid, and even after that we bring about oxidation, then we will be getting carbon dioxide and water. Okay, so this is a stepwise process. That is, when hydrocarbons are oxidized, we get alcohol, and then if alcohol is further oxidized, we get aldehyde or ketone, then carboxylic acid, in the end carbon dioxide and water. When we we are doing your combustion process, what we are getting there, in combustion, simply your hydrocarbon is converting to carbon dioxide and water. Okay, therefore it is called as complete oxidation. Okay, have a look here in the previous reaction, we call it as complete oxidation. And if we control the reaction, so or slowly gradually we bring about oxidation, so these are the products. That hydrocarbon will give you first alcohol, aldehyde or ketone, carboxylic acid, then we will get carbon dioxide or water. So next is oxidation reaction. So what is oxidation reaction? Like for example, if we have alcohol with us, okay, so this alcohol will convert to carboxylic acid if we treat it with either alkaline KMnO4 or we treat it with acidified K2Cr2O7. What is the meaning of alkaline KMnO4? Alkaline means we will make a solution of KMnO4 in a basic medium, okay, or in the presence of base in water. What is acidified K2Cr2O7 or potassium dichromate? This is that we make aqueous solution in the presence of any acid. Okay. So normally we make any solution of compound in water, for example. So simply that compound we dissolve in water. But when we make alkaline solution, we add an alkali, that is base. Or if it is acidified, then we add small amount of your acid. Okay. So when alcohol is treated with alkaline KMnO4 or acidified potassium dichromate, we will be getting a carboxylic acid. So the product which we are getting here is a carboxylic acid. And what is the name of this carboxylic acid? This is ethanoic acid, because 2 carbon atoms are there. Okay. So this is all about your controlled oxidation. Controlled oxidation means stepwise oxidation. Again, if someone asks you that if we bring about further oxidation of this compound, that is your carboxylic acid, what we will get? We will get here carbon dioxide and water if we go on oxidizing this compound. Next reaction is addition reaction. As the name suggests, we are adding something to give a final product, which is the result of combination of compounds. Okay. And one thing which is very important here is to remember that only unsaturated hydrocarbons undergo addition reaction. Why is it so? Okay. Reason is, if for example we take any saturated hydrocarbon, like for example methane. Okay, so this is your methane, 4 bond with 4 hydrogen atom. It is not having, methane is not having any scope to add something else, because in methane 4 atoms are bonded with 4 covalent bond to satisfy the tetravalency. Okay, but in unsaturated hydrocarbon, carbon forms, like for example in this case carbon is forming 4 bond, but not with 4 atoms. With how many atoms one carbon is forming? 1, 2, 3. In the same manner, second carbon is forming with 1, 2, 3. So it is not forming 4 covalent bond with 4 atoms, only with 3. So there is scope of adding something. So always remember that addition reaction is characteristic property of unsaturated hydrocarbon. Saturated will not undergo this reaction. So here we have taken an unsaturated hydrocarbon which is having a double or triple bond. So here we have taken a hydrocarbon which is having a double bond, single double bond. And one more thing here, we have written here R. What is R? This R may be hydrogen or it may be any alkyl group. Okay, so depending upon what is the value of R, we will be getting different type of hydrocarbon. So this is general compound, any unsaturated hydrocarbon, when it is treated with hydrogen in the presence of heavy metal like palladium or nickel. These metals, they act as a catalyst here. What are the catalysts? Catalysts are those substances which are not involved directly in the reaction, but they help to conduct reaction under moderate condition, that is with ease, or the reaction is completed very fast. Otherwise, sometimes few reactions are very slow, they will take very long time to complete. But when we use a catalyst, we can finish the reaction very fast. Okay, in short interval of time we can finish. So here palladium and nickel are acting as a catalyst. Catalyst, you have to remember, this is the catalyst. And what is the idea here? What will happen here? In this case, what will happen? This double bond will break. Okay, when double bond will break, one electron will be free on first carbon and one electron will be free on second carbon. That means both the carbons can form one bond. And here we have hydrogen. So a bond between hydrogen molecule will break and one hydrogen will go to one carbon, second hydrogen will go to the second carbon. So as a result, we are getting this compound. Okay. What is the difference in the reactant and the product? Your reactant is your unsaturated hydrocarbon because it has double bond, but if the product is a saturated hydrocarbon because we have opened up the double bond and we have added two atoms of hydrogen. Okay, so this is addition reaction. Here we are bringing about addition of hydrogen. This reaction play a very important role industrially. That is, earlier for cooking we used to have pure ghee, but nowadays vanaspati ghee or your artificial ghee is also available in the market. What is ghee? You must have seen the pure ghee also. Normally ghee is solid at room temperature. Okay, and why ghee is solid at room temperature? Because it is made up of saturated hydrocarbon. Saturated hydrocarbons are solid at room temperature, while unsaturated hydrocarbon, they are liquid at room temperature. So what you have to remember here, your unsaturated hydrocarbon, they are liquid at room temperature, while your saturated hydrocarbon are solid at room temperature. Okay. What we do when we bring about the same reaction, that is, we add hydrogen to the vegetable oil in the presence of nickel or palladium as a catalyst. Okay, what we will be getting? We will be getting vanaspati ghee or artificial ghee. Always remember, whenever we are having any saturated fat, it is solid at room temperature. So, for example, animal fat is also solid at room temperature. That means what? That means your animal fat is saturated fat. Therefore, fat from the non-veg source is not healthy. Why? Because it is saturated fat. Now, we have given a new terminology here. Your vegetable oil is made up of long chain unsaturated hydrocarbon or long chain fatty acid. Okay. Or your vanaspati ghee is made up of saturated hydrocarbon or saturated fatty acid. What are fatty acid? So write down the definition of fatty acid here. Long chain carboxylic acids are called fatty acid. So fatty acids are nothing but carboxylic acid with the long hydrocarbon chain. That means with large number of carbon atoms. So this is what is fatty acid. So I have written here two examples. Like for example, olive oil contain a fatty acid called as oleic acid, while butter has got a fatty acid, a butyric acid. Now have a look here on their formula. In case of oleic acid, we are having a double bond here. So oleic acid is unsaturated, therefore it is liquid at room temperature, while your olive oil is what? It is liquid at room temperature, while the second one, that is your butyric acid, it is made up of saturated carboxylic acid, or it is a saturated carboxylic acid, therefore butter is solid at room temperature. So this is all about addition reaction. That is, now in lab how can we differentiate? Suppose you are provided with a substance. For example, in a test tube you are provided with a liquid and you have to confirm that it is saturated or unsaturated. How to do this? Okay, what we do, in the test tube where we are having sample, we add bromine water. Okay, so with the dropper, what we are adding here, bromine water or a solution of bromine, and we add, what we are adding very few drops, therefore we are using a dropper. Now as soon as these drops, they come in contact of the liquid which is not having any color, what we are expecting, whenever any colored substance is added in a medium or in water, the same color should appear in the medium. But what we have seen, if this sample is saturated one, in that case this color is there because we have added a color. Okay, but if it is unsaturated, then no color, medium remain colorless. So question arises, where this orange color has gone? Where? Why? Because in this case, if it is an unsaturated hydrocarbon, then we will write down here equation. If it is an unsaturated hydrocarbon, like for example this compound CH2 double bond CH2, okay, so it will react with bromine, and what we are getting, double bond will break, and we will be getting CH2, then we have single bond CH2, and one atom of bromine is added on one carbon, second atom of bromine is added on second carbon. So what we are having here, we have here addition reaction. Bromine is added across the double bond and this double bond will break and bromine will be added across the double bond. Okay, so in case of the unsaturated hydrocarbon, this reaction takes place. This reaction takes place only in the case of unsaturated hydrocarbon. Therefore, your orange red color of bromine water will get decolorized, and it is an indication of unsaturated hydrocarbon. So this experiment you have to remember, that is this activity, that they may ask you a reason that why orange red color of bromine water get decolorized when bromine is added in a sample of any hydrocarbon. This is a sample of any hydrocarbon. Okay. Next reaction is substitution reaction. As the substitution, the term suggests, what is the meaning of substitution? Substitution means one substance is displacing another substance from its place. And substitution reaction is characteristic property of saturated hydrocarbon. Previously, we have done that your addition reaction is possible only in case of unsaturated hydrocarbon because they can add more atom to themselves by breaking double bond or triple bond. But your saturated one, like here, they are attached to maximum number of atom. Therefore, there is no scope of adding any more number of atoms. So what will happen? They undergo such reactions where hydrogen atom of hydrocarbon can be replaced by some other element. So what is substitution reaction? It is replacement of one or more hydrogen of saturated hydrocarbon by chlorine in the presence of sunlight. Okay, here sunlight help to initiate the reaction. That is, reaction is possible only in the presence of sunlight. Why? Because otherwise your saturated hydrocarbons are very less reactive. So in the normal condition, they will not react. And what is the product? If we open up here, we can show methane like this. 4 single covalent bond with 4 atoms. Now this chlorine is made up of, molecule is made up of chlorine atom. So this chlorine molecule will break, and what will happen? This chlorine molecule will replace hydrogen from this compound. So what product we are getting? We will be getting carbon, hydrogen, and then we have chlorine here. Now what is left in our case? Your one chlorine is left. Okay, so this is your chlorine, this is your chlorine atom. So one chlorine is coming here and one chlorine will go here. It will combine with the hydrogen which is being displaced. But this reaction, if it is not controlled, what we found that more displacement will take place. That is, it is not the case that only one hydrogen is displaced. Other hydrogens can also be displaced. So what we found, under the similar condition, your CH3Cl will combine with one more molecule of chlorine under the similar condition, and we will be getting CH2Cl2 plus HCl. Further, your CH2Cl2 will combine with one more chlorine atom under the same condition, and we will be getting CHCl3 plus HCl. Okay, and the last step is that only one hydrogen is left. So your CHCl3 will combine with one more chlorine molecule, and what we will be getting? CCl4 plus HCl. Now in this two products are very important. This CHCl3, this is called as it is chloroform. This is chloroform. Okay, and next one is, that is CCl4. This is a universal solvent and for organic compounds, and this is called as carbon tetrachloride. And yeah, you know where your chloroform is used. Okay, so this is substitution reaction. Here, how many atoms on a whole we are substituting? All 4 atoms of hydrogen we can substitute.